Hey, hello, and welcome to the show. It's me, John Park. It's time for JP's product pick of the week, and I thank you so much for stopping by and joining us over in our various chats, or even if you're not in a chat and you're just watching. We've got the chats over on the YouTube. If you're watching on YouTube, you can join in on that chat. Hello to Dave Odessa and Beata Abdelhagen, Justin Kovacic, and AOT 2002. Hello. AOT 2002 asks, will Raspberry Pi prices drop anytime soon? I have no idea. Sorry. Just don't know. If you're talking about full-size Raspberry Pis, it really seems to be dependent on RAM, as RAM prices around the world have skyrocketed. There's a lot of RAM bolted onto some of those Pis, and the price reflects that. But we've also got, besides that, a Discord chat. So if you're somewhere where you're wondering where the chat is at and you don't know, if you're on Twitch, or if you're on Facebook, if you're on LinkedIn Learning, or if you're somewhere else, head to that's our Discord server. It's at adafruit.it/Discord. That's our webpage that will send you a direct link over to our Discord. And wow, these are dirty. You can look for that live broadcast chat channel right there. You can watch while I clean off these glasses and get ready, because if you want to go and check out the product pick before I even reveal it, you can head right to probably shouldn't inhale the glasses cleaner. That URL or that QR code right there, that is the product page, and we have a deep discount on this week's product pick. Let me go take a look right now, and I think we had 100 of them stashed. So those should now be in stock and on discount. Oh wow, my webpage is being slow to refresh. Hopefully that doesn't bode ill for my streaming connection. No, it all just resolved itself. Yeah, so we have 100 in stock, and we have a 50% off price right now. It is product 5639, like it says right there. I was just double checking. Thanks to Travis over in the new product team for setting those prices and enabling those into the store, putting those into the store, whatever the word is for that. So go check it out. And before I say any more, however, as is custom, when possible, I like to show you Lamore's new video from Ask an Engineer. So here it is. Take it away, Lady Ada.
This very high power infrared LED emitter. We were seeing a lot of people trying to build their own TV Gone type projects or IR controllers. And one thing that is I've learned about infrared transmitters is you really want to drive them really strong to get good range. And you want to hit the IR receiver, even if it's not pointed exactly directly at it, 10 meters away, 15 meters away. To do that, you have to have a bunch of IR LEDs, and you really want to drive them very strongly with a transistor. And so, we have circuits showing how to do that, but it's always people have to get the FET and the pull down and the resistor. So I thought, let's make a little STEMMA board. You connect your JST PH cable on one end. I'll show that. Give it power, ground, and a signal, and then it'll just blast that to 2 infrared LEDs. I picked nice and bright ones. We chatted about that on the Great Search a couple weeks ago. I think these are 90 lumens, or I don't remember. They're as bright as the 5mm LEDs that we sell. You can drive them at 100 milliamp standard, 1 amp peak. On this board, if you give it 3 volts, you're going to get 100 milliamps per LED. If you drive it at 5 volts, you get 200, and I think that's really good, because that way if people leave the LED on, you won't damage it and overheat it. But it's really simple to use. So I thought I'd just show it on the overhead real fast. And what's nice is that this overhead doesn't have, it has some IR cut filter, but not a huge one. So the board comes like this. There is a breakout area if you want to solder to it, but I really just recommend using one of our STEMMA 2mm pitch JST cables. You get a on LED, which tells you that the board is powered, and then this signal LED will tell you when there's signal coming in on the signal line. The red and black are power. Again, 3 to 5 volts works great. When I touch this to 3 volt, you see the signal line, which is human visible. So I can see that red LED. These are not human visible, but they do come through on the camera, because that's how cameras work. And they're really nice and bright. You get two, one edge and one upright. And then if you happen to want, another LED or you want an external LED, we give you one more spot. You can just wire up a standard infrared 5mm LED. In this case, it's a white LED. But then you get one more blaster, and then you can always disable the on LED or the signal LED if you want it to be stealth mode. But just a little easy, inexpensive board with mounting holes just to get people's IR blaster projects going very quickly and very easily.
Yes, indeed. That right there. Let me bring that up. I've got one right here. That right there, that's the product pick of the week this week. It is, out of focus, it is, what are we calling this? I have to check my notes to actually say this properly. Sorry about that. What are you? High power infrared IR LED emitter. It is the high power LED infrared IR emitter with STEMMA board, with STEMMA connection to it. So this is a little board that you can use to connect up to your other projects using a little 2mm STEMMA 3-pin STEMMA SH or JST SH cable. If you plug that in we have a few different of these types of cables available. You can then do plug and play on a breadboard with this one. We got alligator clips I'll show you in my little demo in a second. Couple other options there. You can also solder to, you see the pins there at the bottom. I don't know why I'm holding this up, it's fuzzy and small. But there you can see LED emitters that text at the bottom there. There's 3 pins there. If you flip the board over, you can see that's ground and power, and then the signal. So you send a signal to this board, it then sends that signal to the 2 LEDs, 2 IR LEDs I should say, as well as the little red signal LED. So this has a forward-facing and a upward-facing. So the forward-facing LED is actually a side mount. It is SMD mounted with the emitter heading off to the side there. And then the other points straight up. So this gives you some pretty nice coverage. Each of these are have a fairly wide range. There's a little dome lens on them. So you have a fairly wide range. With 2 of them, you're covering, a hemisphere or so. You can attach on the bottom another LED. So there's a spot there for like a 5mm IR LED. Solder that in on the bottom side, and now you're covering almost a full sphere of IR, especially given that these are powerful emitters. These are driven at 100 or 200 milliamp, depending on, the voltage you're supplying. That'll bounce off of white walls and ceilings and things like that pretty well. So if you're used to IR with your remote controls, this will give you that sort of effect, which is a lot better than just hooking up a bare IR LED to a typical 20 milliamp capable GPIO pin. This is much more suitable for doing real IR blasting. So convenient if you want to make things like TV begons, just something that'll turn on or off every TV around you, running through a series of codes. You can, of course, also use this to make your own very simple. Let's say you want a remote that turns on 3 different pieces of gear for you each time you press it, and maybe one of them is Yamaha and one's Sony and one's JVC. You can feed it those codes, drive this with a microcontroller running CircuitPython or Arduino. We have libraries to make that really easy. And then you can have a little one-button solution that'll do a whole bunch of things for you, little macros for IR. So I love these. These are great. Let's take a look at the product page right here next. And you can see here, this is on sale for $1.98, which is a great price for this. And we have 83 of them still in stock. So what you want to do is just buy this before the end of the show or before we sell out. We don't do any rain checks or back orders or anything on this. So it is priced to sell just during this show at the 50% off, and then it'll go back after the show to the full price, which is not that expensive either way. You can see on the product page here, there under this little add to cart button, there are a few of the different cables. I can jump to that page. So these are the cables that you can plug in. This is a JST-PH, sorry, I misspoke earlier, I said SH, I think. It is a JST-PH, which is a 2mm pitch cable. It has 3 positions or 3 conductors on it. And then we have a few of these. So there is a male header pin version, great for plugging into a breadboard or some sockets on a Feather or a Metro or something like that. We have 3-pin female, opposite version of that. We have a dual plug. This might be useful if you're using, we have a few boards, I think PyPortal, I think Clue. There's a few of our boards that have a 3-pin JST that is the same pin out. So these are generally, we use these for a signal, either in or out, and power and ground. So you could do a straight plug-plug. We have the socket to bare wires, so if you want to extend one of these and solder it to something. And then we have the alligator clip version, which is the one I'll show you in the demo here, which is particularly good for things like the microbit and the Circuit Playground Express, Circuit Playground Bluefruit. So if you scroll down here on the main page, there is a little link to some Learn guides, including the primary Learn guide and some related projects. So here is that Learn guide. Second page of that is the pinout. So this shows you what we have on here. So there's V+, and this can be, generally it's going to be 3.3 volts on most modern microcontrollers, which use 3-volt logic. And you'll want to keep that power the same as your logic level. Or if you're using something like a older Arduino that's on 5 volts, then you could use 5 volt as the power pin and 5 volt as is the logic built onto that. So this will accept either of those. And then we also have the ground pin. We have the input pin, and that is the signal that you'll be sending to it to blink on and off your little LED. As Lady Ada mentioned, this is really for sending IR signal codes, not for illumination. You could use something else to illuminate. This is really for blasting to devices that are looking for IR remote signals. These are on the, I think it's 940 nanometer, which is really typical for most consumer electronics. Then there's the STEMMA JST connector. There's an optional 5mm LED spot on the bottom there. And then there are, if you look, actually I'll show these again. If you look on the bottom there, bottom picture there is the underside of it. There are a pair of jumpers you can cut with a hobby knife for the green LED on top that says that this thing has power, and the red LED on the bottom that essentially blinks at the same time as the IR. So if you want a stealth mode version of this, for some reason, you can cut those and you won't see any blinking LEDs on the top. And then in this guide, we have a little CircuitPython setup and use guide with some sample code and a wiring diagram. And the same goes for Arduino here. And we have the some of the sample code, if you look around, has things like TVB gone, where pretty much every known power off, power on code for every consumer electronic device is in one text file, and that gets read by the code that's running it and just runs all of those. I'll show you, I have a limited version of that just because I didn't want to cycle through all those, but I have a few TV sets set up over here. One's a Sony here. There's another bigger Sony back there. And then this was an RCA. And let me show you my setup here. So I'll hide that for a moment. So I've got a Circuit Playground Express, and then I'm using one of our little alligator clip JST PH cables plugged into the LED board, the IR LED board over JST. And you can see the board's power on is lit. I'm gonna cover the LEDs for a second here just so that nothing gets turned on behind me, but you can see here when I press my A button, the left button on the Circuit Playground, the little signal LED right there is blinking. And it's also making a little click on this, like for haptic feedback. If I get out of the way here and let me show you a better view of things. Let me go to those TVs there, and let me show. Sorry, I'm just going to fix that one. That one got real. Okay, so down there. Oh, TV cam there. Okay. Down cam there. Me cam. Oh, that keeps breaking things. Okay. So you don't need to see me. Okay, so this is, yeah, that'll work. Okay. So this is my left button, which is just going to send the Sony signal. And right now, the way this is positioned, I think only this smaller TV on the top, only that one is going to receive that signal. So I just pressed this. It just went bzzz as it turned on. It's going to take a moment to show you the snow on there. I don't have anything plugged in. And the reason the one in the back didn't turn on is that I'm essentially in the way. There's a lot in the way, and I don't have white paint on the walls to bounce off of. So in a second, I'll lift this up and turn them both on. But first, I'll press this second button here. And what that one does is it runs through a few codes, including the Sony and the RCA code. So this should turn off the top TV and on the bottom TV here. So you can see that one, when it's got no signal, it just happens to go to a blue screen. I can turn the Sony by itself back on. Again, it's just clicking my remote and bouncing that all around. And then I'll turn them both off with this one pin. So that just runs through those codes. And just to demo, before I show you the code, I'm going to actually unplug this. And I'll just go to a view here where you can see. I have this plugged into a battery, so I can still use this plugged into a little LiPo battery. And I'm just going to position this so that all of the TVs can see it. So I'm going to turn on the two Sonys, and so you'll see that big one in the back of my workshop come on, as well as this little one. And again, these are not plugged into anything, so we're just going to see static on those. So you can see those are on. If I press my second button on here, I should turn those two off and turn the RCA on. So let's see. Boop, those two went off. Bzz, and the little RCA should be warming up. No, it didn't see it. All right, let's give it some help there. There it is. I don't know if it got tired or what. So let's take a look at what the code is doing here. This is running in CircuitPython, so I've got this little IDE view. Oh, that's a good view right there. Yeah, we got all the cameras at once. So over here, this is my code. This is based on the example code that's in the Learn Guide. I just adjusted it a little bit, and the key things here are we set up a pin to be the IR blaster's output. So in this case, it's pin A2. And then I'm also setting up the speaker. I'm setting up the two buttons to read. And then I have this function right here. Lady Ada wrote this. So this is the IR code send, and then it takes an argument of which code you're sending. It opens up from a text document that you feed it a set of codes to sort through. And then it looks at the repeat value and the delay value found in there for the timing that's used, and then it grabs that each line in that table and sends that out using Pulse.io. So here's the Pulse.io library, which is built into CircuitPython, and this is used for pulsing out those high-low signals. You feed it the frequency, the duty cycle, and then the pulse array from that text document. If I connect down here in the REPL, let me plug this back in. It's not currently plugged into the computer. And I'm going to trigger the Sony. You can see there it says send A, and then this is the text from that document about what is the IR code and frequency, duty cycle, repetition, all of that. The other button runs through a few of them. So when I press that, you'll see I'm sending 4 different codes. I think there's a Toshiba in there, RCA, Sony. The table, I'm going to open up the codes I'll do the Sony power one. That one's straightforward. So that's the same as what you saw printed out there, right? So that's the text document. Lamore wrote some code that generated a really nice text document for all of these. Here's the full codes. This is pretty much every single consumer device we're likely to run into. If I'm not careful and I run that one, it'll probably turn off my air conditioner as well, because that's on an IR. So you can have some fun. That takes about 20 seconds to run through all of those, but you can have some fun finding out what in your environment is going to respond to an IR remote code. So that is the demo of that. Let me turn off that. Let's see if I can do it from here. There it goes. Okay, I think I turned off all the TVs. Phew. So let me reattach that, and I'm going to check out the chat and see what's going on over in YouTube. Happy Hansa says, I used one of these to program a remote control interface for my home stereo system. Excellent. Also programmatically control my artificial candles. They all accept simple IR commands off the shelf. So I made an automated control interface for them. That's great. And I used an IR receiver from Adafruit to read the commands from the existing remotes. Yeah, so that's those are cool projects, and it brings up the point. Let me go back to this right here. If you look on the product page, which I'll go ahead and refresh, we have 80 of these in stock. There are a couple of breakouts listed on the Learn Guides, and one of them is the receiver breakout. So this is a good pair to have. So this TSMP 96000 IR receiver breakout, you can use that to listen to. So a couple things you can do. You can take existing remote controls, boop, 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 point them at stuff, and learn the codes right off of them, which is great. And then you can send them using today's product pick. You can also just set up communications between two of these. It doesn't have to involve any consumer electronics. So if you want two microcontrollers to talk to each other, you can find some good examples we have of just using the Circuit Playground, I think the original Circuit Playground and maybe the Circuit Playground Express, to talk to each other over IR. This would just supercharge that, since it's a much beefier signal, and the receiver is I'm not sure if the receiver differs, but this sender is higher current, higher brightness of the IR LED essentially. Yeah, Dan Cogliano, could be an alternative to an RF transmitter receiver setup. We're thinking along the same lines. Definitely, you can do things like send serial back and forth, make little games with them. Pretty neat for stuff like puzzles and escape house kind of stuff. A lot of neat uses for IR. I love it. I still miss when our devices used to come with them, like the Game Boy Pocket had IR, all the Palm Pilots I had IR. Furby had IR. In fact, I remember using a learning remote app on the Palm 3 to learn what the Furby said and then say it back to the Furby and make it think it was having a conversation and losing its mind. It's a lot of fun. Kind of repetitive after a while. Okay, so that I think covers it. This, in the Learn Guide, there is a page that shows you what IR side mount. I think it's the same, pretty much the same as the top mount one, just a different shape. But this is an Innolux SMD LED. It's 1206 size, so super tiny. And yeah, peak wavelength is 940 nanometers, which is what pretty much all these IR things use. So if you wanted to read up on it, any of the info, it's there in the Learn Guide on the last page. Okay, I think that's gonna do it. Let me see if there's any other questions in the chats. Yeah, Happy Huncha says, I did have to do a little detective work to figure out the decoding for some existing remote signals. Yeah, I will tell you, this is probably something that a LLM like Claude or ChatGPT is really good at, is helping you craft some tables of IR based on the existing stuff out there. So, okay, I think that is going to do it then. Let me pull this out of here and we will wrap up. Don't forget, if you want to go pick up some of these before the price goes back up, that is the QR code and the URL right there. I'm going to do my homework again. What is your name? What are we calling you? I got to look on that. It's not actually written on there. You are the high power infrared IR LED emitter, STEMMA JST PH 2mm. All right. Then we'll finish this up. That right there is my product pick of the week this week. It is the high-power infrared IR LED emitter with STEMMA PH-JST connector. For Adafruit Industries, I'm John Park. This has been JP's Product Pick of the Week. See you soon. Bye-bye.